I've tried to replicate the notes that we had in the previous video, at least all the important stuff. And if you notice, we use the term Michaelis-Menten a lot on this page. We have the Michaelis-Menten model that features the Michaelis-Menten complex. And we have the Michaelis-Menten equation that mathematically describes the Michaelis-Menten plot and its hyperbola. That's the key here. Michaelis and Menten were some scientists, about 100 years ago, that actually did these experiments where they went ahead and measured the velocity of enzyme reactions as a function of various different substrate concentrations. They plotted those velocities and they saw that it came out to be a hyperbola. They developed all this theory around it. Now the thing about hyperbolas is that they always have the same shape, but they can differ in two different parameters. You have the height, that is where it levels off. That's the Vmax. And what I'm going to tell you about is that's really all about catalysis. That tells us how good is the enzyme at doing the second part over here, where once the substrate is bound, how fast is it turned into product and spit out? That's the first parameter that's going to affect the hyperbola. The second one is how far is it shifted from right to left. You remember we talked a lot about the shift of hyperbolas and sigmoidal curves when we did oxygen saturation curves in myoglobin and hemoglobin. And how far it's shifted right or left is going to be reflected in the Km. The Km is the substrate concentration that gives us half Vmax. Now the Km is parallel to P50 when we were talking about hemoglobin and myoglobin. And if you remember, hemoglobin and myoglobin's P50 had a lot to do with the binding affinity of whatever was binding to it, in that case, oxygen. So, the take-home message of this little review is that we have the dual nature of enzymes. They have binding specificity issues, and then they have chemical reaction catalysis issues, and the Vmax and the Km in some way are related to that. That's why the Michaelis-Menten plot that we can make in the lab is very useful to us. So let's move down and talk in a little more detail about what these parameters mean. I'll try to keep the whole thing on the page so that we can see it while we write. Okay, let's go through the Vmax. The Vmax we can define in a bunch of different ways. It is the initial rate of the tangent of the hyperbola. It's a bit of a mathematical definition. Really, all that means is it's the point, if we were to estimate where the hyperbola levels off. Now, mind you, the hyperbola gets closer and closer to a tangent to Vmax, but it never really reaches it. So it can only ever be an estimation if we're looking at this data. Now, mathematically, because it's a tangent, we would say that the Vmax is the initial rate when the substrate concentration is equal to, well, infinity. You never actually get there. You can't get there in a laboratory setting, but you can only approach closer and closer. So mathematically, it's only when the substrate gets to infinity. Okay, before we move on, I want to ask you a question. We did this before on our different plot, and I'm going to ask it again for the Michaelis-Menten plot. Why do you think the curve levels off in this case? Take a moment, pause the video, and see what you think. So when I ask this question in class, I can often get somebody or a number of people to give me the right answer. The answer in this case is we level off because when we add so much substrate, it saturates the enzyme. So when we get to the Vmax, it really means that all of the enzymes in your tube are filled with substrate and they can't go any faster. So that's another definition for Vmax. It's the initial rate when all enzyme has substrate bound. And we're going to finish off Vmax by telling you what the units are. Vmax is a velocity, so we're going to simply use velocity units. And we said previously that the units for velocity were the micromole of product made per time, like seconds or minutes. Could be either. Okay, so that's what Vmax is. And like I said before, we consider this has something to do with catalysis. Let's move on to Km. See if we can fit it all on here. Km, we already said what the definition is. It's the substrate concentration when velocity equals 1/2 of Vmax. It's a very useful thing because we can use our graph to determine it. We can go to Vmax, down to half Vmax, over to the curve, and down to Km. Now, Km can also be defined in another way. The Km is the substrate concentration when the enzyme is half full of substrate. That's kind of a funny thing to say. What I mean is consider a population of enzyme. When half of that population has substrate bound and half of it doesn't, whatever substrate concentration gives you that is the Km. Now the units of Km are also given or seen in the definition. In both of those definitions, we said it was the substrate concentration when some condition is met. So, for units, we're going to use typically concentration units, maybe millimolar or micromolar or molar or nanomolar, whatever. It's going to be some concentration. Good. And what we said is that this has to do with binding. Now, these two words in orange on the right, we can clarify a little bit more. If the Vmax tells us something about catalysis, that is, the height of this curve tells us how good the enzyme is working, we got to be a little more explicit. If the Vmax is higher, that means faster. And if it's lower, that means it's slower. That is the chemistry step that occurs after substrate's bound. What about binding? What about the Km? Remember we said it's kind of the equivalent or parallel to P50. What did we say about P50? Do you remember? We said that when it's lower, it's tighter. So in this case, the lower the Km is, the less substrate you have to get half saturation of the enzyme. The tighter the substrate binds to the enzyme, the better the hand fits in the glove, that is, the lower the Km is going to be. So Km is very similar to P50, and I think we're going to leave it at that for this video, and I'll do a short video to talk about this last parameter called Kcat, because that's a bit of a subtle variation.